And welcome, everybody. It's great to have you here on CCNA Sunday. In this live stream, we are going to focus on some techniques and attributes regarding network address translation that have, frankly, been plaguing the world for a long, long time. Because I bet you that 6 out of 10 times when I hear somebody explain these concepts of inside local, inside global, outside local, outside global, it's not correct. A lot of times, or it's a textbook's definition and they're like just reading it. I'm like, oh, let's do something different today. And what I would love to do in this focus session, as we take a look at the show output of NAT Translations, I would like to share with you a way that you and I can get our frame of mind around this, understand it better. So going forward, whenever you see that output, you'll think, oh, I know exactly how to decode this. I get it because I learned it based on analogies, based on something we know, and that's our objective. So before we take a look at the show NAT Translations output, let's take just a moment and chat about network address translation, what it is, some options for setting it up. We have a previous session in the stream for NAT that we did with source NAT, and I just want to do a quick recap to make sure we're on the same page, and then we'll take a look at the show NAT Translations, and you'll be pleasantly surprised at how good you'll be able to interpret that output after this short session today. All right, so let's take a look at the desktop, and let's start with this. Let's imagine, I bring my pen up, and I'm having a crazy hair day, by the way. I just got out of the shower, and it was like, nah, it's not cooperating. Let me give you a full view here. Beaker style. All right, yeah, it wasn't cooperating, so there you go. I'm looking at myself in the feedback monitor. All right, back to the desktop. So if we have a client or a device that is on a local network, let's just imagine a computer right here, and that computer is Larry's computer. I have a couple fond memories of a person named Larry Roberts, who I worked with many, many years ago. He's maybe a triple CCIE these days, super smart, so admirable, and I see him like once a year at Cisco Live and say hi. It's always great to see him. But so I thought of Larry. I also have another friend named Larry who is never going to see this video because he's not in IT. Anyway, let's imagine this is Larry's computer, and Larry starts with L. We'll just remember that for a moment. And then Larry's on this network, and Larry is got an IP address, and he's got a default gateway that looks something like this, a router. Now that layer 3 router could be a multi-layer switch. It could be a traditional router. And also this represents right here, this segment represents a VLAN. So physically, Larry's computer is probably connected to a switch, and that router is connected to the same switch in the same VLAN, or a switch in the same VLAN, and they've got connectivity, and then this router can go out to the world. So we'll say this is other networks. Maybe that includes the internet. Great. So if Larry has this IP address, let's use this network, 10.16.0.0 with a 24-bit mask. Join us for Subnet Saturdays for that full discussion. And we'll have Larry be at .10. So that's his IP address. He's happy. He's got a default gateway. I have his router at .1. Let's imagine that's the default gateway address. And so if Larry wants to talk locally on this network with other devices, no problem. He's on the inside of his network, and from a company perspective, and he can chat with these devices. If he needs to send packets to another network, maybe we have the 10. crazy pen. Keith's got crazy pen. 10.16.6 network. That's a different network. And maybe there's a host over here at .101. If he wants to talk to that computer or that device or that server, he would forward frames to his default gateway at layer 2. And at layer 3, the destination would be that IP address 10.16.6.101. The router would get that frame, look at the destination IP address, make a routing decision. The routing happens at layer 3, and the switching forwarding happens at layer 2, and it would then forward it on to its destination. So that's all well and good until Larry, going through the network, is trying to get out to a server that's on the internet. And the problem with an address that starts with 10 is that it's a private RFC 1918 address. So RFC is a request for comment. It just means that It's a group of IP addresses that everybody's allowed to use internally in their companies, but on the internet, service providers will not forward those packets. Not because they can't, it's because they won't. It's like, nope, those are RFC 1918 addresses, and those are simply anything that starts with 10 is one of those private addresses that anybody can use inside their company, and then you can subnet that to smithereens. There's plenty of room there, or the 172.16 through 31, anything, and the 192.168 anything. So those are 3 of the private address ranges that Bob's company, or Larry's company, is using as they do this. So if we're going out to the internet, the challenge is we need to translate Bob's IP, force of habit, sorry about that. We need to translate Larry's source IP address into a routable internet address. So maybe this router is connected to the internet. Maybe it's got an IP. Let's pretend, just for a moment, let's pretend that this outside network, the pseudo internet, is 192.168.1.0/24. Now, you might be saying, Keith, I see that's a private RFC 1918 address. So in a lab environment, you can use those private addresses in your own environment and make a pseudo internet out of it and have pseudo servers. IP addressing is IP addressing. And in this case, we're just going to play. Imagine with me, pretend with me, that network address space represents something that's globally routable on the internet. And so if we wanted Larry to go ahead and be able to communicate, maybe we have a server here at .100, 192.168.1.100, we'd have to have some type of network address translation that would swap out Larry's source IP address and replace it with a routable address that the internet could use. So in this topology, that could be routed out here. And so to do that, what we'd do is this. Let's just make a little table here. Let's imagine that we'll call this R1. R1 is going to be our router that we are going to be doing network address translation on. Now, this doesn't have to be a router. It could be a firewall. It could be some other device at layer 3 that's swapping out the IP addresses. But somebody has to do NAT, network address translation, between Larry and the public internet that doesn't allow that type of routing. So NAT, another word for NAT is lying. We're lying about an IP address. So we're going to play a switcheroo game. And let's imagine that, let me make this a little bit bigger. A little bit bigger. Eraser. And by the way, everybody who's answering questions and chatting in, thank you very much for all that feedback. We'll have a little Q&A at the end. So if you have questions directly for me, you can save those or repeat them once we get to that point. I'd be happy to go ahead and take them on. So Larry's address, if we're doing network address translation for Larry's packets as they go through this router, let's say this is the inside network. I use it, yeah, that's good. Let's imagine this is the inside Larry's local world, and outside we have the outside world where we're translating addresses to. So inside just as a concept, outside as a concept. And as Larry's packets are going through the router, if we're doing something called source NAT, where we're translating or changing the source address, let's just walk through that. So this line represents before, and that here is after. So before and after the network address translation. So before, Bob's source IP address is going to be 10.16.0.10. That's his source address. And the destination address is the server. In this case, the server is at 192.168.1.100. So that's the before picture. So that packet as it's traveling here on this inside network is source address, destination address, no problem. But the magic of NAT is source NAT is that this router running NAT is going to have some rules in place that say, hey, if I see any source addresses in the 10 network or whatever we want the rules to be, in this case the 10 network, go ahead and swap those out and replace them with a routable address on the internet. So on this router, let's imagine we have .5 as its IP address. And this, again, for the moment of this discussion, let's imagine that the 192.168.1 network is routable on the internet. And if we have this IP address, .5, we could actually train the router to go ahead and swap out Bob's force of habit, swap out Larry's source IP address of 10.16.0.10 and put its own IP address of 192.168.1.5 as the new source address before sending it out. That would be doing NAT. And that flavor of NAT is referred to as port address translation. In Cisco, we implement that with the overload command. Or if we want to do a static translation, we could just say, hey, Larry, we're going to translate your address from 10.16.0.10 to, and I'll put this in a slightly different color, to, instead of being .10, we'll translate you to 192.168.1.10. So that would be the mapping. And if we did that, and that's referred to as a static NAT, where we're just doing one IP address on the inside, meaning before translation, one address on the outside. Then after, the source address would be 192.168.1.10, and the destination address would still be the server. We haven't changed that. It's still going to 192.168.1.100. So this is before we implement network address translation and after. And this is referred to, now look at this output real quick. What is being swapped out? What is being translated or changed from the before and after picture? Is it the layer 2 addresses specifically in this layer 3 header? No. And in this layer 3 header, this layer 3 information, what's being swapped out? And you might say, well, Keith, you just swapped out this guy, which is the source address of Larry, is now mapped, which is a great way of thinking of it, swapped out to this IP address. So network address translation is swapping out an IP address as it goes through that NAT device. In this case, it's router 1 acting as our NAT device. And there's some terms that we could use for this. And because we're swapping out on the initial flow of traffic, because we're swapping out the source address, this is literally an example, and I'll put this in a different color so it's readable. This is an example of source NAT. Because we're on the initial flow of traffic, we're swapping out the source address. Larry's address was 10.16.0.10. We're swapping it out to 192.168.1.10, and then we're forwarding that packet on its way. So on the initial flow, whatever's being swapped out, that's the type of network address translation that we're doing. And it gets a little bit interesting as we take a look at some other options for that, but that's source NAT. Also, if we create a static translation where we say, Larry, your IP address of this is always going to map to this one-to-one, that's also an example of what's called static NAT, because we are hard coding it. There's no if, ands, or buts. That's the rule. Now, if we set up dynamic translation that said, okay, Larry, when anybody in your subnet, based on your source IP addresses, when they go and their traffic is being routed out to the internet or across this NAT device from the inside to the outside, what we'll do is we'll have a rule in place, but we won't create the translations until you start using them. That's referred to as dynamic NAT. D-Y-N-A-M-I-C, NAT. And again, the NAT refers to one-to-one translation. So one computer on the inside has its own IP address on the outside. There's also the options for overloading, which we talked about, which just basically means we could tell the router, hey, listen, you don't have any IP addresses on the internet to spare. You've got this one IP address that you've got on your outside interface. Just use that. And what it'll do, based on the rules, it'll take all the traffic that's going through it, and it'll map it to that one IP address. And to track all that, it's going to play with the port identifiers, the port numbers, like for TCP and UDP ports, to keep track of all the sessions. That way it can take hundreds or thousands of different IP addresses going through, and it can translate them all to its own source IP address, and then it can go ahead and keep track of those based on all the ports. And that's referred to as port address translation, where you have many on the inside mapped to one on the outside. So those are all mix and match flavors, and there's more. There's several more. But I just want to give you a heads up on some of the options that exist here. And it's called source NAT because we're swapping out the source IP address on the initial flow. Now, what is often not described, in my opinion, which should be the second discussion here after NAT, is untranslating that address. Because here's what happens when the server gets that packet. Let me use a different color for this. I use kind of a golden color. If this server on the internet, and so on the global internet, on the global network, like not where Larry is, this is the local side of the house. Out here we have global, so we have a global internet. Everything else is not Larry locally. Companies like Google, parent company Alphabet. Google is an example of a big company that's not inside Larry's local environment. So Google and other large players are considered global players, global enterprises, the other networks that are not outside of Larry's control. So when a server like this at 192.168.1.100, when it gets a request in, if we've done translation for Larry, the internet sees this request as coming from 192.168.1.10. And as a result, that server, if it sees that request, it's going to go ahead and respond. So if Larry makes a request to the web server and we're using this as a translated address, all the internet knows, all the global side of the house knows is that, hey, I got this request from 192.168.1.10. And the internet, for all intents and purposes, thinks that's Larry's address, or the address he should respond to anyway. And so he responds back to that address, which should be routed back to this router. That's an important part of NAT. If we're doing NAT and we're mapping to addresses that don't belong to us, where the internet can't route back to us, those packets are, it's like the Roach Motel. Packets check in, but they never come back. They don't check out. So the return path would come to router 1, who would then take a look at this thing called the translation table. And here's our translation table right here. It's a fancy way of saying keeping track of what I did for network address translation. And this reply, when it comes back to 192.168.1.10, the NAT device is going to say, oh, yeah, I have that translation in my translation table. I know that's really 10.16.0.10. So what it does for the return traffic, it untranslates it. So now we're taking the destination address, going back to Larry, and we're untranslating it back to the real address, then forwarding it on. Now, why would that still be an example of source NAT? This is an important discussion. It's the initial flow. The initial translation, which was generated by Larry going out to the internet, that's our major intent. That was the packet that was translated, and so it's referred to as source translation and our source NAT. And that's a great way to think about it too. And when you're just learning network address translation, you hear the concepts of source or destination NAT. Just think on the initial flow. What's the intent? Whose IP address is being translated? If it's the source address for the initial flow of traffic, it's source NAT, even though the return traffic will be untranslated and sent back to the client. All right, so I have a question for you. It's pretty important too. People can disagree on a lot of things. I've been wrong in my life on very major things more than once. And so I've learned over time, as I hear somebody else's point of view, it really would serve me to learn more about what they think, why they think that. You know, everybody's looking at their life, at the world through their own map. And it's important to learn what other people think. And so I just thought to myself, if we had a situation where we had, let me go ahead and hide my pen for a moment. And let's imagine we had two people that were chatting. These are two kids, but they could be two adults based on their backgrounds and so forth. They could be arguing about many things, seeing things very, very differently. Let's imagine that they're looking at a tree and that tree is leaning, right? So maybe it's leaning this direction. So is it leaning towards the right or is it leaning towards the left? And they could be arguing about that. Like, hey, well, no, it's right. No, it's left. Well, it depends on the context, which is a fancy way of saying it depends on your viewpoint. If you're standing like on this side of the tree, it might look like it's leaning right. If you're standing on this side of the tree, the other side, it might look like it's leaning left. You with me? It just depends on your point of view. Also, like a wall that has a curve to it. Is it convex or is it concave? Meaning, is it curved in or curved out? It depends on which side of the wall you're on, your perspective. And we have that same exact challenge when we're dealing with network address translation. Because the internet, like where Google is and all the rest of the world, they may see our addresses that we're sending, our source addresses, as one IP address. That's the one we translated. And then Larry, on the other hand, on the inside of the network, from a local perspective, he may see it as something else because Larry thinks, hey, my IP address is 10.16.0.10, where Google or the outside world may see it as the mapped address. Are you with me? It just depends on your perspective. Where are we looking at the IP address? Whose eyes are we looking through it from? So here is what I would like to offer as an idea that is going to be very, very helpful as we discuss network address translation. I'd like you to think of Larry. And I went through this many times with, okay, should I use Lois here? But I use Lois as a user example. I'm going to stick with Larry. And I'm going to attribute this to Larry Roberts, an amazing technician who I met and got to know about almost 20 years ago. So this is not a picture of Larry. This is a stock photo. So if you get a chance to meet Larry Roberts, do it. He's a good guy. So Larry's a local, meaning he's local to the network. He is a local like in Vegas. Sometimes locals have a different attitude or perspective of Las Vegas than tourists do because they're coming from the outside. So I would like you to think of Larry's a local, Larry's a local, Larry's a local. And I'm using the word Larry, the name Larry, because it starts with L, and the word local starts with L, and Larry's a local. It's going to be hard. In fact, if you tried right now to think, I'm not going to remember Larry's a local, Larry's a local, I'm going to think about it in some other context, it's going to be hard. Larry's a local, meaning he's on the inside of the network. He is like an admin or a user on the inside of the network. So IP addresses that he deals with are from his perspective. Larry's a local. And then everything outside Larry's enterprise, like the internet and everything else from a global perspective, and I use Google as an example, or parent company Alphabet. Think of Google as from a global perspective. The Google doesn't know the details unless they're hacking him. The details of Larry's local network, they don't care. But they do have a perspective. Like if Larry sends a packet out to the internet and we map it, the global perspective of what that IP address is going to be different than what Larry's local real address is because we've done translation on it. So I'd like you to think of this as the two kids that are looking at something from different perspectives. And I'd like you to remember that Larry's a local and that companies like Google and the rest of the world out there are looking at it from a global perspective. They're looking at it from two sides of the house. That's going to become very important to us and useful, as you'll see here in just a moment, as we take a look at network address translations. So let's do this. Let's bring up, wow, not that. Let's bring up this topology. This would be a good discussion point for us. So we're going to imagine that we have R1, which is a router, a layer 3 router. Could be a multi-layer switch with three VLANs, doesn't matter. So it's a routing device at layer 3. And off of it, I put little clouds because the actual details of the individual switches and other routers off of those interfaces isn't really important from a perspective of NAT. It's just that off of 00 on R1, it has reachability to a network called 10.16.0. And that's where Larry's computer is. I'll put a little L there for Larry. And off of gig 200, or off of gig 20, it's got reachability to a Las Vegas network, which is 10.16.8. And it's also got access to a network in Florida. I know those are geographically pretty separate, but you know, with WAN technologies, it's possible. So we have a network of 10.16.20.0 with a .101 for a Florida device. And these are all considered on this left-hand side to be the companies. We're using private RFC 1918 address space. We're doing routing, and we may have OSPF running. We may have static routes. Perhaps we have IPv6 as well on these networks. But all of this is from the local perspective for that organization who designs and manages those networks. All right, so far so good. Then, off of gig 1/0 on R1, we're connecting to an outside world. Like for this in our pseudo internet, we're going to pretend that this address of 192.168.1.1, we're going to pretend that's the internet, and other addresses that are not in our control, that are out there, that we might have to do NATing for. And so one of the key elements is if our topology kind of looks like this. Let me bring up a pen, or bring up this. If our outlook kind of looks like this, where everything to the left here is the inside, that's our network, our local domain if you want, and then everything that goes out to the internet is considered outside, that's a concept that will hold true for a lot of things, including firewall services. So in a firewall, we set up domains or areas or regions that are like trusted inside, although we don't really trust everything inside, and then untrusted outside, and then perhaps a DMZ from a security perspective, just to kind of give a flavor of which interfaces lead to what type of networks. And so with NAT, which is the focus here, here's what we could do. We could just say, well, we want to tell these interfaces here, 0, 0, and 2, 0, 0, and 2, 0. So I've been working on a few different models of switches and routers lately with 3 characters for the port numbers. So 2, 0, and 1, and 0, 0, we could say that, hey, dear Mr. Router, those interfaces, from a NAT perspective, are going to be considered inside interfaces, meaning anything off those interfaces, go ahead and consider that our inside network. And to do that, we just simply do IP NAT inside. I'll put little spaces there as well. So that's the command in interface config mode we do on 0, 0, and 2, 0, 0, and 2, 0 to make it happen. Woo! I take a sip of water. All right, and then while I'm taking a sip of water, I'd like you to guess what would be the command on this gig 10 interface if we were going to tell that interface that it was associated with the outside world. Just take a wild stab. Thank you for that. So if you were saying, well, Keith, yeah, I think the command here on gig 10 would be IPNAT outside. You'd be right. And that's how we define or delineate the inside networks from the outside networks from the perspective of NAT. That way the router has a clue when a packet comes in and it makes a routing decision. If the packet is coming in on 0, 0, or 2, 0, and based on the routing, it's going to be forwarded out 1/0, then from a NAT perspective, that traffic would match any NAT rules for traffic going from starting on the inside and going to the outside. That'd be for an inside source NAT, for example. That's how it knows. It makes a routing decision, looks at the interfaces involved, and says, oh, is this going in to out, or is it going out to in? Do I have any NAT rules that match that? And if it does, it uses those NAT rules and does the translation. So that's part of the story there. And I think what we had to do is, let's do an example. Let's help reinforce this right now. Yes, do that. Let's do a NAT rule. And I would ask for volunteers as far as what we should do first, but there are so many potential options here, including PAT and NAT pools, that let's just spell one out that says we're going to take Larry's computer that's coming from the inside and going to be routed out. And let's specify that we want to translate that from 10.16.0.10 to, let's map him out to something on the outside. Let's do 192.168. I'm just doing this for my own benefit, 1.10, just so I can have a visual. So we'll create that mapping. It would go something like this, and we'll verify the syntax in the CLI. It'd be IP NAT. Good start, Keith. Good start. Keep going. And make sure I didn't. Okay. IP NAT inside, which basically says traffic that is sourced on the inside as it goes to this NAT device. IP NAT inside source, because we're doing source address translation. We're going to swap out the source address, IP NAT inside source, and we'll use static. Now, instead of using static, we could call on an access control list, which then matches based on those source addresses that match the access control list, and then that would be matched. Here, I'm just going to do a hard code mapping just for Larry. So IP NAT inside source static, and then the address that we're going to do the translation for, 10.16.0.10, and a space, and then the IP address that we want to map him to, which is 192.168.1.10. And then we'd also do the interfaces and say IP NAT inside, IP NAT outside to make sure it knew which interfaces were in and out. So let me go ahead and let's go ahead and do that. I'm gonna hide the screen for a second. Boink. And let's go to an interface if I have one. Give me one moment. And let me line this up. All right. I just loaded this lab a few minutes ago, so hopefully it'll cooperate with us. That looks like it's lined up. All right. Put in the password. And I'm going to go back to our diagram for a moment just to verify the interfaces. So 0, 0, and 2, 0 are going to be inside NAT interfaces. 1/0 is going to be the outside. So let's configure that first. So we'd go back to the command line interface. And let's make sure we're on the right device. Yeah, based on my knowledge of this router, we are on the right device, and there's our interfaces. So just as a reminder, we're going to do 00, it's going to be an IPNet inside interface. Gig 20 is going to be an IPNet inside interface. And gig 1/0 is going to be our IPNet outside interface for the purpose of this lab and this topology. So we'll go into configuration mode. Let me go ahead and put my camera back on. Hello again. Interface gig 0/0, IPNet inside. Da-da. And we'll go to interface gig 20. And we'll do IPNet inside. I could use the up arrow key from that. And then we'll go to interface gig 1/0, and we'll do an IPNet outside. So what that, I'll back out one level. So what that command just did for us, now the router has an idea. Okay, I don't have any NAT rules yet, but I know that if I do have a NAT rule, I have an idea of which interfaces are associated with the inside. That's Larry's domain, and which interfaces are associated with the outside world, that global world that Google and the rest of the world is in. Although we could do NAT inside of our network, and it also works the same as far as the concepts of setting up the rules and having a match. So at this point, what's a good idea to do? Let's do because we're in configuration mode. So we'll do show IPNet statistics. And it's good to verify as you go. This just verifies that our outside interface is gig 10. Let me check our topology here. That's this guy right here. That's good. And then our inside interfaces are gig 00 and 20. Again, we'll check our topology. That's this guy and this guy. Okay, I just want to make sure that we are on the right track. So our next step would be to create that translation for Larry's computer. Now, before we create that translation for Larry's computer, let's do some due diligence and verify that Larry's computer is what we think it is. So let's go to a command prompt here on Larry's computer and just do an ipconfig, which on Windows is how you see the IP information, and it is 10.16.0.10. And also, just for grins, I want to make sure that we have access to that server that's across R1, which is at 192.168.1.100. Just to verify we have basic connectivity first. So we'll do a ping to 192.168.1.100. Okay, we have connectivity. And I'm just going to go for the whole shot then. Let's open up a browser, and let's go to that IP address again. Now, when we use a browser and we put in an IP address, it assumes that the application layer that we want to use HTTP. And that's why I don't have to add HTTP in front of it. It's going to assume that as a default. And it will forward the frame. The TCP SYN request, the three-way handshake is going to happen. So the TCP SYN is going to be sent to the layer 2 address of the default gateway with the layer 3 address of the server. And then the routing will happen. The packet will show up at the server. It'll respond back with the SYNAC. And then finally, we'll have a final acknowledgement from the client. And then the actual conversation for the web page can happen. And because of the magic of networking, it just happens so darn fast. It's great. But we can verify it too. Check this out. On this Windows computer, we can do a netstat space. Now, if we don't want it to do name resolution or show the protocols, we can do a dash. It's either D or N. It's not D. So if you do a trace route, TRACERT-D, that's don't do name resolution. And this is, I'm looking at right here. The option is display the addresses and port numbers in numerical format rather than their, so I'll do a -N. Press enter. And what this shows us is that we have a current session from our local address, 10.16.0.10, going to 192.168.1.100. Our source port is 1545 for that session. And the destination port is 80, which is the well-known TCP port for our web server. And it's in established state. And I imagine that will time out after a period of time, or if we shut the browser, that'll go away. But I wanted to verify that works. And if we go back to router 1, which the traffic is going through, and do show IPNAT translations, and we can shortcut that. I'm just spelling it out just because you'll see, so you see the whole command. This is showing us our current NAT translations in place. And we don't have any because we haven't created any yet. So the traffic is flowing. It's not being translated by NAT yet. Let's fix that by creating a translation. So to create a translation, we did it on the screen earlier. We'll do it here. IPNAT inside should probably type that correctly. IPNAT inside source. So we're doing source address translation. We're swapping out Bob's source IP address as it goes through, or will be if this rule matches. Yeah, IPNAT inside source. And if you had an access list, we could use the keyword list. If we are going to call on a route map for some tricky matching, we could call on that. If we want to just do a static mapping one-to-one with NAT, that's what we'll do. Just put it in. And then it's asking for Bob's address, Larry's address. Forgive me for that. So Larry's address is 10.16.0.10, and then the address that we want to map him to. And I will give you some context sensitive help on that, which is, what do we plan on? Let me bring up my layer. I want to make sure I'm doing the same thing. Yeah, so here's our mapped addresses, 192.168.1.10. That's what I'm mapping to, 192.168.1.10, which in this lab environment, the pseudo internet knows how to reach back to that address space, and that R1 owns it. And we'll press enter. Now we have IP. If we do a do show IP NAT statistics. Now here's what we know. We have the outside interfaces gig 10, the inside interfaces are gig 00 and 20, and we have one static translation. That's what it says right here. And if we want to see that, we can do a do show. Again, the do is only required because I'm sitting in config mode. If we're at the privilege mode prompt, pound symbol, all by itself, we can just do the straight up command show IP NAT translations. That'd be great. Do show IP NAT translations. Okay, so there's our translation. That's this address right here, the inside local address and the inside global address. And I'd like to pause here. And I'd like to talk about these with you because this is the discussion that every time I looked at these online at like 3 or 4 different examples, and most of them were just the instructor or the trainer saying, and they're done. And it's like, I don't think a student, in my heart, I don't think a student who saw that would get it and be able to interpret a routing, a NAT table after that discussion. So we're going to solve that, and we're going to do it in a very creative ways with some things that you already know. Check this out. I'd like you to imagine Larry. Where does Larry live? Think about that. Larry's on the inside of his network, his own local stuff, and we'll put Larry as local, and we'll put Google representing an outside entity, somebody on the outside world, everybody else even, the whole internet. We'll represent Google. That's a combination of Google and global in one word. Google as global. And do you recall the discussion we had about perspective? Like, what do you believe? Is the tree leaning left or is it leaning right? It depends on your perspective. So anytime, and this is the takeaway for now, and then we'll apply it here in a moment. Anytime we see the word, let me get out a highlighter here, red. Anytime we see the word local, did I say anytime? Yeah. Anytime we see the word local, I'd like you to think of, oh, that's from Larry's perspective. That's what Larry believes, his point of view, based on which side of the tree he's on or which side of the NAT he's looking at IP addresses on. So whenever you see local, every time just think of Larry's local perspective, the local view, what he believes. Think of it as belief. And then whenever you see the word global, I would like you to think of that from the perspective of the outside world. Like Google, what do they think? Where do they think you're coming from? If we sent a packet from our home networks and we went out to google.com, 8888, or ping that address, Google would not see our own private IP address. Google would see our translated address. So Google and the rest of the world, these global entities, they would see us as that translated address, whatever it happened to be. They wouldn't see us as our. So the perspective is different. So in this output right here, show IP NAT translations, every time you see the word local, it's Larry from his local perspective. It's a perspective. It's what they think. It's what they believe based on how they're working with IP addresses. And so let's take this local and global being the perspective from the outside world, and let's look at this translation right here. So in measurable terms, we've got a user, Larry, who's at 10.16.0.10. He really is. And then we've got a router 1, and then we've got the rest of the world, including including global and everybody else, but we have one server that we're pretending is on the internet now is 192.168.1.100. So I've got a question for you. Is this really Larry's IP address that we just demonstrated? Yes, it literally is. And on the server that we're hitting, is this literally the IP address 192.168.1.100 of that server? And in this lab environment, yes, it is. It really is. And so if we were to ask the perspective of Larry and saying, hey, Larry, what's your local address? Or what's your address? He would say 10.16.0.10. And if we asked Larry, hey, what's the address of the server you're hitting? He would say, oh, it's 192.168.1.10, 100. So it's a lot like, let me draw one more layer here. It's a lot like the perspective of the inside and the outside from these perspectives. So it's Larry saying, I think the inside is this, and I think the outside is this. And on the other side of the coin, we have, from a global perspective, what they think the outside is and what they think the inside is. And the thing I would like you to remember as we look at this discussion, as the bells and the light bulbs start to go off, is that whenever you see the word local, it's from the perspective of Larry inside the network, what he believes the IP addresses are, which is going to change here in a moment. So having the word local in your mind, that's Larry's perspective. So right now, if we ask Larry, hey, Larry, what's the inside? What's your IP address on this PC? And Larry would say, oh, it's 10.16.0.10. And if we ask Larry, hey, what is the IP address of the server you're going to? He'd say, oh, it's 192.168.1.100. Now, if we ask Google or the global community what the addresses are, the global would say, from his perspective or its perspective, hey, the outside address is 192.168.1.100, but the inside address, does the global internet think that Larry is at 10.16.0.10? No, because we did the translation. It's right here. We translated 10.16.0.10 as it went through NAT to this address 192.168.1.10. So the global perspective would be, okay, our address out here is 192.168.1.100, and we've got a connection coming in, thinks the global perspective, that's coming from an inside address that appears to be 192.168.1.10, because that's what it believes. And here's how that can help significantly. Now that we have been slightly indoctrinated on those terms, let me show you why those are so stinking powerful. Look at the output of show IP NAT. Look at the output of show IP NAT translations right here. I'm going to highlight a few pieces, including local, which I'm going to write Larry right there. Local, Larry. And that's Larry's perspective. Every time it says local, that's Larry's perspective. So let's just do this exercise right here with Larry. Hey, Larry. Hey, oh, you know what? Let me do one more translation, and I'll put it in the same spot. I need to get a little more. This will work. This will work. So from Larry's perspective, we'd say, hey, Larry, what is the inside address? Basically saying, Larry, what do you think the inside address is? He says it's 10.16.0.10, which it is. And currently, we aren't playing any games or lying about the outside. So if we sent more traffic and we had the translation present for this, we could also see the outside resource would appear from local Larry's position as 192.168.1.100, and I will bring that up because that's important to see. So I'm going to hide that. I'm not going to erase it. I'm just going to hide it. Let's go back to the PC, and I'm going to just hammer this a few times. All right, so I just did refresh like 4 or 5 times. We're going to have several connections there. We'll do a show IP NAT translations. There we go. So the previous one's timed out, and I'll put my overlay up here. There we go. Through the magic of editing and a couple movements of the mouse, there we go. So now from Larry's perspective, if we ask Larry, hey Larry, from the inside, what is the IP address? He'd say 10.16.0.10 right here. See that? And if we ask Larry, hey, what is the IP address you're going to? From your perspective, what's that IP address on the outside? He would say it's 192.168.1.100, which it is. So anytime in the show IP NAT translation, it says local, I want you to hone in on that, as local means the perspective of Larry. Local Larry, what he believes the IP addresses are, and that's what it means. That's what it's representing. Now let's undo that. And let me go ahead and clear that. And let's take a perspective. Oh, you know what? I'm going to undo that. Undo, because I want to leave some of that up. So let me erase Larry for a moment here. Thanks for your patience on that. And now let's ask the same question, but let's ask it from the perspective of Google or global or somebody on the outside. Hey, what do you think is happening here? And if we wanted to focus on the global perspective, which is all this is, from the global perspective, somebody on the outside network looking at the IP addresses, here's what we're going to do. We're going to focus on that word global in this output. They are on the far ends, not my fault. That's where they are. And this is the global perspective. This is like the Google outside world perspective of the addresses. So if we went to the outside world and we said, hey, what is the server that's trying to be hit here? From the outside perspective, it'd say, hey, it's right here. It's 192.168.1.100. And so that's the global view of the outside IP address for this translation. It's 192.168.1.100. I mean, that part is pretty straightforward because we're not doing destination NAT yet. I'm going to change that up here in a moment so you can see it and still use the concepts. So, and then we asked, hey, Mr. Outside World, this server just got a request from Larry. Hey, what do you think? What do you believe from your outside global, from your global perspective? What do you think that source address was? That the address that was coming from the inside network of where Larry's machine is, what do you believe that is? And that's over here in this column. And from the global perspective, the belief is that the packet came from this IP address, which is the one we translated on behalf of Larry. This will serve you well forever if you want it. The global simply means what's the perspective from the outside looking at the addresses. The local means you're looking at it from the perspective or the belief system of the inside users, like Larry. Larry's local, Google's global. That'll help you remember those terms. And then as we're looking at the inside outside, remember how on the router we said IPNet inside over here and IPNet outside here? That's all it's referring to. Which side of the translation are you talking about? And or what is the belief regarding before and after NAT? So from a global perspective, they don't know the real address, but they believe it was coming from the address of 192.168.1.10. So that's a key element in memorizing or learning the show IP NAT translations and making sense of it. You know what I think we should do? I think we should do another example where we're lying to both sides, because that one I rarely get to see in a demonstration. And I think it'd be important because you can use this concept. Let me go ahead and go to the big screen for a minute. You can use this concept that Larry is a local. It's his perspective of the IP address inside and the IP address outside, or global, its perspective of the IP address inside or outside based on the mappings. It's not very often we get to see the other side of the coin with the destination server also being translated. So what I think we should do is this. Let's add another translation rule in, and we're going to lie to both sides, meaning we're going to do translation on both sides. We'll translate Larry's address, which we've already done. We'll also translate from the outside going in. We'll also translate the IP address of the server at .100. And that way we can see both sets of addresses being mapped and changed when there's a communication path between them. I think this will be fun to do. I hope it works out great. I'm thinking it will. Yeah, I'm thinking it will. Let me clear off this. And let's go to our whiteboard. And let's plan out what we're going to do, and then we'll do it. Our intention is we have a mapping for Larry. Oh my gosh. I got to stick with Larry today. So Larry's translation is from 10.16.0.10 going through the router, and the mapped address is 192.168.1.10. So that translation is already done. That's source NAT from inside to outside. What we could also do is we could do a translation for the server at 192.168.1.100. As it goes through, we could make it look like 10.16. I need something routable. 6.100. So routing has to work, by the way. If your router routing decisions are made before NAT decisions. So if the router doesn't know how to forward a packet or doesn't think it should route a packet, it won't go through the pair of interfaces and it won't check for NAT rules. So you're going to trust me just for a moment that this router knows how to get to the 10.16.6 network. Actually, it's hanging off of one of these two right here. It's directly connected. I think it's off of gig 00. But so it has reachability to that. So for the server, what we're about to see is an example of two-way NAT, where traffic going from Larry this way, if it's going to the server, I'll put that in yellow. If Larry goes to this IP address of 10.66.100, it's actually going to be sent to the server. And when the server responds to this address, it's actually going to be forwarded back to Larry. Yeah, it's not pretty, but that's literally what's going to happen. We just need to add one more translation rule to make that happen. And then we can actually see the translation table. And the whole goal of this session is so that you understand Larry's local, his perspective of the addresses, and then Google's global and his perspective, because that will serve you every time you look at IP NAT translations. So let me clear off that screen and hide that mouse, and let's add another translation. So let's take a peek at what we have. Show IP NAT translations. So the reason it's currently not showing any current sessions is because there's no traffic in use. The HTTP session from the client has timed out. So this is just showing us the static NAT rule that we have. Currently it's not being used. Otherwise we'd see the connection information. With TCP and UDP, it shows the ports as well. For ICMP, it has a tracking mechanism. It would show us ICMP for ping. But currently we have no translation, so let's create a translation. And we can also use the context-sensitive help now that we know that Larry and Google Global, the local and global options, they'll make sense here more now when we do the commands. So we'll do an IP NAT outside. Because we're doing outside NAT. We're going to translate the source IP address of traffic coming in on the outside, meaning our server, as it's being routed through an inside interface. So IP NAT outside, we're doing source address translation, and that source we're going to do static, and we'll put in the server address of 192. Context. Yep, check this out. Look at this for a moment. Let this sink in. Outside global IP address. This is when many people melt down and say, oh, global, blah, blah. Give me an example so I can figure it out. Well, what does the word global mean? It means the perspective from the outside. So imagine you're Google or somebody on the outside network sitting there, and now they're asking for the actual address on the server that's outside. It's the literal address on the outside as seen from the outside. That's what the global means. So it is 192.168.1.100 space context sensitive help. And now it's asking for the outside local IP address. Let's take a moment. Let's just bask in this for a moment. What does local mean? Let's start there. There's only two words that you really need to remember to kick this off, and that is global, which is the Google's perspective from the outside world, and local, which is Larry's perspective. So whose perspective are we asking about now? Larry's, local. So from the local inside network, what do we want this outside address to appear as? That's effectively what it's saying. From Larry's perspective, what server would he go to? What are we doing this mapping to that Larry would then use and believe is an outside address from the local perspective? And that address is going to be 10.16.6.100. Local and global. Every time you see the show IP NAT translations, it says local or global, think of those perspectives. And this is a smidgen above CCNA, but I'm going to do it so it'll work. I'm going to add a route. Now you might say, Keith, why do you have to add a route? Good question. Let's talk about that. Let's imagine that you and I are a router, and we're directly connected to a network. And somebody does an ARP request looking for an address on that network. Or somebody else on that same network is trying to talk to another device in that local network. We're not going to bother forwarding it because it's for the local network. Well, the mapping that we just did for the outside server at 192.168.1.100 to an inside address of 10.16.6.100. That's on the inside. And so the router would say, yeah, that network's over here. I don't need to route it. And that add route command says, oh, by the way, for this static route, add a 32-bit static route that says, if anybody's looking for this IP address, the mapped address, the inside local address, go ahead and actually forward it over to the outside network and to the outside host at 192.168.1.100. We'll save that discussion for CCNP and very likely CCIE. You do not need to know that. That's not required knowledge for the CCNA, but if you want bidirectional NAT to work and you have the interfaces where I have them and the network's involved, you got to do it if you want it to work. So that's that. And we could also see that by doing a do show IP route static. And there is our static route. So it basically took the mapped address right there, 10.16.6.100, and it says, hey, to get to that 32-bit address, go ahead and forward it to 192.168.1.100, which is the real server on the other side, on the outside. All right. So let's do this. Let's do a show IP. I'm so excited. Do show IP NAT translations. So these are examples of static translations. We've got 2 of them. If we do a do show IP NAT statistics, there it shows our 2 static translations. Now at the moment, none of them are in use because we don't have traffic flowing through, but it's ready. It's like, okay, I've got these rules. If traffic comes in from either the source address of 10.16.0.10 or it comes in from 192.168.1.100, I'm going to go ahead and do the appropriate translations. So if we want to see this filled out and actually in use, which I would like to, let's go back to our client PC. And from our client PC, I'm going to close that browser. I'm going to do a ping to the mapped address, which is 10.16.6.100. So that would be an example of Larry's perspective of local outside. Larry believes that's the address, or he should because we just mapped it. That's the address of that outside resource, the outside server, although we've mapped it to an internal IP address. So that's Larry's perspective of the outside address. So we'll do a ping. I'm so glad that worked because you can't get a translation in place and see it unless you have traffic. So I'm actually going to do a dash T, let that run for a moment. Dash T simply says just keep them coming. And then we'll also bring up a browser, and that way we can see multiple translations going through the same time. So here's a browser, and we'll go to 10.16.6 as I think about it, .100, which is the mapped address that we set up for the outside host. And that's working. And I'm going to run over here to the server real quick and do show IP NAT translations. Great, got some of both, and I can go and stop our ping. We'll come back to this in just a second. Okay. Now, most people who would be working with this, who are fairly new to IP NAT translations, would look at this table, and they would say, I don't know. They would just give up, say, I'm not sure how it works. But here's how we can approach it, you and I, now that we have our information about Larry. Who has a local perspective on the IP addresses, and also Google, which has a global perspective on those addresses. So I would suggest that we take a look at just one perspective first. Don't look at both of them. Like, what does Larry think? What does the global world think? Let's just take a look at one of them. And so let's take a look at Larry. So we're just going to find the 2 columns in the middle that have the word local. That's Larry's perspective. And we have 2 sides of the network, inside and outside, as defined by our IP NAT inside and outside statements on the router. So we could draw a router here. There's R1, there's the inside, there's the outside. And from Larry's perspective, he believes that the inside addresses are 10.16.0.10, and that's the only translation we have in use right now. It's the only one that is there. Here's the whole list of the ones that are in use. So ICMP is being used. We have a couple of sessions for TCP using these two respective ports as source ports, and that's what Larry believes. Larry believes that the source addresses are this column. Larry also believes that the device that he's talking to on the outside world is this column, which is 10.16.6.100. That's his belief system. So these middle two columns, that's Larry's belief system about where he's coming from, the addresses on the inside and the addresses on the outside from his perspective. And I will use a different color as we discuss the global option, which is from Google or the outside world's perspective. We can forget about Google now. I just wanted to get it into your minds that global, global, global means the perspective from the outside world. So what does the outside world believe the addresses are? Well, we have two columns for that. We have this one and this one, because they both have the word global in them. So from a global perspective, they believe that the outside IP address of the server is 192.168.1.100. Just like that. That's literally how it works. So they think, the outside world thinks, yeah, that server's literally at 192.168.1.100. And as they take a look at the Bob's address on the inside, they don't see Bob's address as 10.16.0.10. They see it as the mapped address. So as we communicate with that mapped address, if we take a look at from the global perspective, the inside addresses from their perspective, we're looking at 192.168.1.10. Again, it's a belief system. So this one here is the belief system from the global perspective, and this one here is the belief system from the local perspective. And that's what these four columns are showing us. This is absolutely something that I wish I had come up with as far as explaining it with Larry local and G global and Google global. I wish I had thought of this 2 decades ago. It's a little sad, actually, that I've never taught it this way before. I thought I just need to spend like an hour or two figuring out a way that when any human who wants to decode what this means can do it. And if you start with Larry and his belief of what the IP addresses are, and then global, meaning the outside, what their belief is of the addresses involved, you can sort it out every single time. All right, so that's it. Inside, local, outside. Oh, yeah. Inside, global, inside, local, outside, global. I'm done. Too long. Didn't read. Got to go. But that's how you can decode it. Just think of local, meaning it's from the inside perspective on the addresses involved. Global means it's from the outside perspective, the addresses involved on both sides. And when you're doing bidirectional NAT, which is exactly what this is, we're lying to both sides. And that's how it works. It's like, Keith, is this going to be on the CCNA? No, not at this level. But I can tell you this. If somebody showed you an output of show IP NAT translations, which is fair game for the lab or for the CCNA, you'd get it right. You could say, oh, this is what it means. The global means the perspective from the outside world, and the local means perspective from Larry on the inside world. And you could then not reverse engineer, but answer a question based on that. All right. I think I've said that's an hour. I didn't intend on spending an hour on that, but I did want to give you examples, hard-coded examples of bidirectional NAT, and lead up to it with the story of Larry and Google as local and global on their perspectives. All right. I'm not going to lie. I had a lot of fun in putting this together. So again, some regrets that 15 to 20 years ago I didn't come up with that story or that idea. If you are pursuing your CCNA, we are so glad to have you here. If you already have your CCNA, and a lot of us do in this channel, but we want to brush up, or like, oh, I'm going to get this tip, or I'm going to help other people in the channel, we're glad to have you too. All the people who are supporting each other and helping each other, great. We're all coming from different backgrounds and different levels of experience. Our focus in this channel is CCNA, which is the associate level Cisco certification for 200-301. The other day, I got some feedback on a video. It says, well, your intro was like 10 times louder than the actual content. And so I did two things. One is I went back and I snipped off that beginning part because there's just some music and a banner, and I toned it down. And then secondly, I responded and said, I'm so sorry. That was from, I think it was from 2005. No. 2000. It was from many years ago, maybe 5 or 6 years ago, when that video I said, please check out our new content. Here's the CCNA playlist. Enjoy it. And I did both of those things. I wanted to fix that. I always like to get better and better, and I'm amazed when I come up with I look at an old video and I think, oh, what was I doing? I mean, the technology is accurate. I'm teaching it correct. My teaching is better these days too. It comes with practice. But so it's fun it's a little fun. It's a double-edged sword to look back at those old videos. So if you enjoyed this session, or if you want to learn CCNA, I would encourage you to do 3 things. Number 1, if you haven't already, click on subscribe. Secondly, when you do subscribe, if you hit the alert bell, it'll let you know when the live streams happen. They usually happen 3 times a week, and then I add them to the playlist. Secondly, schedule time. Get Packet Tracer, which is free, or if you have live gear, that's fine too. But schedule time to both study with a book or videos or whatever mechanism you want to use, and then do hands-on practice. Don't just take it for granted that, oh yeah, I see how that works, it's good. Go ahead and lab it up and get that practice, because in certification and in the real world, it's going to be helpful the faster you can respond. It's all about stimulus, pause, response. There's a stimulus, something happens. How long is the pause going to be before you can respond correctly? And in production environments, we want that stimulus, pause, response, that pause to be very short and be very accurate. So we know what to look for, and labbing it up will help with that. Also, because it's on top of mind right now, a few sessions ago, we did variable length subnet masking, and we started with the biggest networks and worked our way down, which is the way I've always done it. Always done it. And somebody asked, well, could we start with the smaller subnets and work our way bigger? And I thought, I don't know, I just never done it. Lab it up, try it out. Maybe that would work. And then, this is so great. I mean, learning just never stops. So Bob and a few other people and Van Ray, I think, I apologize. There's several people discussing it. And they said, in Packet Tracer, I tried to go in variable length subnet masking. And join us for Subnet Saturdays for that. I went from smaller to larger, and it claimed there was overlapping networks. And so I looked at it. I looked at the IP address ranges on paper, and I thought, oh, well, let me lab this up. And I put it in Packet Tracer, and it said overlap, when it didn't really overlap. The IP addresses were unique. The mask, it was when you're going from low to high, smallest networks to biggest. And so I thought, this is one exception where Packet Tracer didn't get it right. And then somebody, I think it was Bob, in the audience or in the Discord channel said, I just labbed this up on live gear. It does the same thing. I'm like, what? So I labbed it up, and I was the most surprised ever, because I did the subnetting in reverse order. I used loopbacks. I did it reverse order, smallest to largest, and on live gear, it barked about an overlapping IP address with one of my first. And I thought, these do not overlap. These do not overlap. These do not overlap. But it's true. So I went back and I said, Packet Tracer didn't lie. Packet Tracer was telling us that they wouldn't work. So I learned something brand new in the last 48 hours. And that is when doing custom subnetting. I've always done it from the largest subnets to the smallest. That's how I've been trained and done it for decades that way. Never tried it the other way. And if you try it the other way, it fails, which is a great, at least it did in the scenario we had in Discord. So check that out if you want. So which is a great reminder for us that when you're curious about something, lab it up. Spend a few minutes labbing it up like I did, and then verifying it for yourself. Oh my gosh, this doesn't work. Why is that? How is that possible? Which is still was my question, and still is a little bit like, why these IP addresses do not overlap? Why is it giving me grief? But anyway, small to large didn't work. So I wanted to pass on my thanks to the Discord channel for helping me discover that brand new thing after working with Cisco since 2009 or 2008. Yeah, no. I got my first CCNA since 1999. You slipped a decade there, Keith. Yep, so I'm grateful for that. Okay, here's what I'd like to do for the Q&A regarding this section. I would love to take any questions. We're going to take a short break, and I'm going to grab some water. I'd like to have any questions that are related to NAT at the CCNA level, which basically is going to be the basic foundations of NAT, like static NAT, dynamic NAT, using a pool, always source NAT. They're not going to ask you about destination NAT inside of CCNA. I demonstrated bidirectional NAT just so I could show you the inside, outside, global, local perspectives, which is important to know. So anything regarding NAT would be great at the CCNA level. If you want to help other people, you can answer questions. Also, I'd encourage you going forward from this point on, instead of scrolling all the way back through the list, which there's been lots of great comments, please feel free to ask. And if you have a question for me directly, just do an @KeithBarker in this chat, and then I will see it and then be able to answer it. And that includes you have questions about the concept of local and global. I'm happy to go over that again. But the idea is that you're going to have different perspectives. If you're on the inside of the network or the outside of the network, you're going to have different perspectives on what the IP addresses are. And so when you use the word local, you're asking from the perspective of the inside network and regarding the inside and outside addresses. And if you have the word global, you're looking at the addresses, the inside and outside addresses from the perspective of somebody on the outside network from a global perspective. So using the keyword local for Larry will help. That's the two middle columns. Those are focused on the perspective from inside the company regarding the translations, and then global represents somebody on the outside network regarding the addresses involved. So local and global, that's the two keys, and then everything else is perspective based on local or global perspective. All right, I'm going to take a quick break, grab some water real quick. We've been going strong for 70 minutes, and we'll be right back, and we'll take some questions. Thanks.
Life is a winding road, no telling where it goes. Driving through days and nights, won't stop for traffic.
Okay, and we are back. Let me bring up my section here for Q&A. So over on my left is my Q&A, and I'll move the mic over just a little bit. So I'm going to be focusing here to read the questions, pick up the questions, and if there are any questions, I'd be happy to take a look at them. Again, CCNA focus would be preferred. Anything outside of CCNA, I'd like to put in the Discord server. Okay. I had a great weekend, by the way. It was a lot of fun. Work hard and play hard sometimes is a great thing. Within moderation. All right, let's start with Darshan. Okay, Darshan, your question is about bidirectional NAT, and you're talking about asymmetrical routing. That's way beyond CCNA, so I'm gonna pause that one. And if you want to put it in Discord in the other section, I'd be happy to have the team look at it and think about that and answer those questions. But again, I want to make sure I'm focused on CCNA related or level topics. And if I think it's close to CCNA, I will definitely elaborate on it here. All right. And John, we're working at CBT Nuggets. We are working on the Encore and the other courses for CCNP. We're pedaling as fast as we can. So thanks for the interest. All right, moving down. Okay, I've got a question from Norman asking, how can somebody join your Discord server? And let me bring up a link. I'll just paste it real quick. And I'm hiding behind the mic. Sorry about that. Discord is free, as is this YouTube channel, and we encourage everybody to cooperate and ask questions and learn. There is a set of rules on that Discord page. When you log on and subscribe, you'll be made a member. I have a little bot that does that for us, and then take a look at the rules, make sure you agree. And the basic element is be a nice person, help other people, and don't disclose or share anything that you shouldn't be disclosing or sharing based on any agreements you've made with Cisco or vendors if you purchase their products. We want to make sure we're keeping everybody authentic and real. All right. So there's the link, Norman, for the Discord server. Thank you for that question. Okay, Adolf. Oh, thank you, Adolf. Adolf saying, by far, this is the most easy to remember explanation I've come across. Oh, thank you very much. Adolf, this discussion I just did today about the Larry Local and Google Global and having those two perspectives. I created that in the last 48 hours, and I did it as, let me just reveal. I did it in preparation for Encore because I'm teaching this concept at the CCNP level. And I thought I just need some way for somebody who's doing NAT to absolutely, every time they look at that, whether it's bidirectional NAT or source NAT or destination NAT, or whether it's, source NAT from the outside coming in or source NAT inside coming out, which are both bidirectional. I want to make sure they can understand it. So thank you for that feedback. I appreciate that. Okay, let me see if there's anything else. If you do have a question, and you asked it before, I'm just starting from here going down, so please do an at Keith Barker if you have a CCNA related question, and I will be happy to look at it. All right, Shady Network's asking. Shady Network, I love it. That's a fun name. That's what I mean. What are some practical scenarios for bidirectional NAT versus... Oh, what are some practical scenarios for directional NAT versus bidirectional NAT? Great question. And the answer for that is most companies are going to be using... Well, let's back up a little bit, and let's imagine you're at your home. And at home, it's very likely you've got internet access through Wi-Fi. Let's imagine that's the case. So you've got Wi-Fi access. And the way we got that is we have an access point in our home. It may be built into your router, but some kind of a Wi-Fi signal in the 2.4 gigahertz range or the 5 gigahertz range using 802, using whatever technology you're using. Maybe it's N or AX or etc. Anyway, using some Wi-Fi technology. When your computer gets an IP address via DHCP, and it gets a default gateway of your router. And let me make sure I stay on topic. Practical, great. So you're being given by DHCP by default on most home networks and small office home offices something in the private RFC 1918 address space, which could be the 10 network or 172.16.31 or 192.168, anything. And those addresses are great for your local, your Amazon Echo. I don't want to say her name because she'll talk to me. Amazon Echo, your Google Home, your smart Samsung smart things, your home automation, your refrigerator that has an IP address, your TV that has an IP address. All those things can communicate with each other directly on those local network. But if any of those devices try to go out to the internet, those source IP addresses, let's say you have the 10 network or the 192.168 network address space, the internet service providers, if you're using those source IP addresses, they won't allow those on the internet. Now, there could be several layers between us and the internet. So I could be connecting, my current provider here in Las Vegas is Cox Communications. And so with Cox Communications, they could have several layers of routers and NAT and things that they're doing as well. But somewhere in the path between my home network and our home network and the internet, somebody's doing NAT. And that would be an example of directional or standard NAT, network address translation. Specifically, it'd be source NAT. Because as our packets are going out to the internet, our source addresses, let's say we're going to Google at 8.8.8.8. We're doing a ping, or we open a browser to some internet resource. We do a DNS resolution for the IP address. The packet goes out. Our source IP packet has to be translated at some point before it goes out to the internet. Otherwise, the internet devices, the internet routers from the service providers, when they see it, they'll say, yeah, I'm killing that. This guy's trying to source the packet from a private RFC 1918 address space. I'm not going to allow it. So it'll kill it. So our service provider or our home router actually will do a flavor of address translation. And it's probably PAT, port address translation, where it has one IP address on its outside interface. And then it considers everything coming in to be inside. And so it'll do dynamic NAT, source address. We could call it 5 things. We could call it source address translation. We could call it dynamic NAT. We could call it dynamic PAT, because we're mapping all these inside addresses, your IP TV, your refrigerator, your Internet of Things devices that communicate out. They're all being translated to the one IP address on the outside interface of your router, which may also have a private RFC 1918 address. And then further down the road, your service provider is doing that again to swap out that source address. So most of the time, I wouldn't say 99%, but I'd probably say 95% of the time, we're going to do single direction translation, like source NAT going from your home out to the internet. Or if a service provider has a server, we could have destination NAT, where clients are going to this global routable IP address, but we're doing destination NAT to swap out the destination IP address on that initial flow to the actual IP address of the load balancer or the server on the inside. And then, of course, whenever there's a translation, whether it's source NAT or destination NAT, a unidirectional translation, there's always an untranslate. So if somebody did the initial translation of a source address for the return traffic, we're going to untranslate that address and put it back on the original address. If we're doing destination NAT, meaning we're swapping out the initial IP address for the destination, like somebody on the internet, like Bob, now I can say Bob, going to an internet resource at a public address behind the scenes, they're probably doing destination NAT, which is swapping out that destination address we put in our packet right before it gets to the load balancer or whatever the device is, and then it actually translates the destination to the real address of the server. And then on the way back, they're doing an untranslation as well. So the experiences I've had with bidirectional NAT usually involve somebody screwing up with, well, I shouldn't say screwing up, somebody who has to make a terrible situation work. Like I mentioned Paramount Pictures, that was my first exposure to that. Paramount Pictures got bought by Viacom. They kept the name, or Viacom's the parent company, and they had 10 networks. We had 10 networks, meaning the 10 address space. And how do you get 10, 10, 10 over here to talk to 10, 10, 10 over there? The answer is you don't. They're two separate VLANs. They're not the same VLAN. They're across the country. And so we have to involve DNS for resolving names to certain IP addresses, and then we have to make both sides appear as different subnets. So maybe this side of the network thought it was talking to 10, 10, 20, and this side thought it was talking to 10, 10, 30, but in reality, we're doing destination NAT and source NAT to make those communication paths lie to each other. Nasty business, but possible. It's in the tool set. A little bit above beyond CCNA, but those are the cases. So shady network, thanks for that question. All right, let me look at Dino's question real quick. Okay, so Dino's question is a good one, and that's asking when doing NAT, I say in general, he's asking on a firewall, what is the order of execution, routing, NAT, or ACL? Great question. It can depend on the vendor. So routing is a routing decision. Like here comes the packet in, the ingress interface, looks at the IP header. Do I know how to route? Do I make a routing decision? And then what's my exit interface? What's the next layer 2 header? And routing. That's routing. Now, if you have an access control list in the mix, the question is, are we going to do a routing decision first? Or are we going to check the access control list first? And that's going to depend on the direction of traffic and where the access control list is. So, and these are both CCNA topics too. So if you have a packet that's going this direction, and you have a router in the middle here, if you have an access list inbound on this interface where the packet is coming in, the ingress side, it's going to be the access list first that's checked to see whether or not that packet should be allowed. And if it passes the access list, then the router can make a routing decision and then make its forwarding decision. If that same scenario, but we have the access list as an outbound access list on this interface and the packet's coming in here, unfortunately, well, depends on how you slice it. The packet coming in, the router would make a routing decision, and then I'll identify the exit interface and then see the ACL on that exit interface or egress interface and then do the blocking. And there's reasons for both. And routers these days are so darn fast. They've got caching and Cisco Express forwarding and hardware that, like 2 decades ago, so it depends on where the access list is. And then furthermore, NAT, the routing decision has to happen before NAT. Because if you have an inside interface and an outside interface and 2 other interfaces, unless the packet is coming in on the one NAT interface and being routed, a layer 3 routing decision out the other interface, so this is IP NAT inside, IP NAT outside, then it can say, it matches. Let's see if we have a NAT rule or an existing NAT translation that's in use that I can go ahead and use. That's important. Now, if the traffic was coming in this interface and going up another interface or down another interface that is not enabled for NAT, there'd be no NAT translations or NAT rules in place. So the way it works is there's NAT rules that we can have in place, and then once those rules are matched, then the translation happens. And if there's an existing translation, the router is going to say, there's an existing translation for this. I don't need to make another translation. It's already there. And the ports involved, when you do a show IP NAT translation, those ports, let me show you this. This is pretty darn cool. The ports involved. And let me log back into this again. So if we looked at this, if we did I can go out of configuration mode because I'm done. If you do a show IP NAT translations, I think these should all have timed out. Okay, so what we're seeing here is we're seeing our rules in place, but they're not in use at the moment. There's no traffic flowing through them that would cause them to be used. If we want to cause them to be used, we could go to a device. I will close this window for ping. I will close. Sometimes you hit refresh here one time, it won't actually go to the server. So I'm going to spam it. I'm going to do it like 3 or 4 times just to refresh. And let's go down to R1, which is our NAT device, hit the up arrow key, and that's because I hit enter. I hit refresh 4 times. And so it actually went out and made 4 connections, and it used these ports. So I forget, how does this work again? Remind me. He says with a little bit of a chuckle. How does this whole thing work again? As far as I know, we have router, and I know we have the inside, and I know we have the outside. We define those with our IPNet inside, outside, and we have our rules in place, and we sent some traffic through. But what's this whole thing about the local perspective versus the global perspective, which I will put in a different color? Because that's really the 2 things I want you to pull out from this session, is that just looking at the word local, I want you to think of what Larry, oh, wrong color. Stop. Let's go back to this color. I want you to think of what Larry, what his belief is from the local perspective regarding source and destination. So Larry believes the inside address is 10.16.0.10 for this session, and he believes the outside address is 10.16.6.100. That's not literally the address of the outside server, but that's the belief system because we mapped it. We have bidirectional NAT. We mapped the 192.168.1.100 over to this IP address, and that's all Larry knows. All he knows is his perspective of the inside. If we go back to the other side of the camp and we go to global, what does global believe about the addresses? Well, from the global perspective, the global believes the outside address is really the address of the server, 192.168.1.100. And from a global perspective, on the outside of the network, it believes that the entity who's coming and connecting to that from the inside of our network is this bad boy, 192.168.1.10, which isn't true. That's not really Larry's address, but from the perspective of the global outside regarding where that packet's coming from, that's what it believes. It's all about perception. Larry is looking at it from the inside network. What does he believe the inside and outside addresses are? Global is from the Google or outside world's perspective. What does it believe the inside and outside addresses are? Just what do they believe? What are the mapped addresses? And doing the bidirectional NAT, the only reason I did it in CCNA is because I wanted to give you a hard-coded example that you can use for CCNP, for CCIE, for the production environment. And just every time you do it, a show IP NAT translation, say, okay, there's a lot of output here, but let's take a look at this from the perspective of the local, the inside. What's their perspective of these addresses? And then separately, what's the perspective from the global outside view for the inside and outside addresses? And that'll help. So what was the question there? I started ranting. Keith, you're ranting. Let's see here. Let me go back to my questions. Oh, that was all about NAT on a firewall. What's the order of execution, routing, NAT, and ACLs, which I think we addressed. Thanks for the question, and thanks for letting me elaborate on the local and global options. And Larry Roberts, hope to see you at Cisco Live. Cisco Live, they canceled at Melbourne not too long ago because of the COVID-19. So we'll see about Cisco Live in June, whether they hold it or not. I have no idea if it's going to go or not. I hope it does. I'm teaching there 2 classes with Jason Gooley. It's going to be fun. All right. TGA 4991, you are very, very welcome. All right. Murray's asking, can you please explain source NAT versus static NAT? Let's talk about that for a moment. Great question. Let's go to the whiteboard. And let me use this topology right here, or let me use this backdrop right here. And I'll just keep extending it. That way I'll leave this here. Bring my mic over. Okay. So the question is source NAT versus static NAT. I think the best way to approach this, let me see if there's room for my face on here. Barely. Okay, hi. The best way to approach this is one at a time. And let's take a look at static NAT. Static NAT is when we put a rule in place like this one right here. This is an example of a static NAT rule. We're not dynamically saying, oh, if somebody shows up from some source address and we're being routed through interfaces with NAT, then we'll create a translation for them. That would be an example of a dynamic network address translation. Case in point, if we said something like, let's say we have access list 1 that says permit 10 anything. And here's how we spell 10 anything with a wildcard mask. Like that. So we have this access list that says permit anything. And then we could do, and this router, let's imagine, I'll just draw it right here. So there's router 1, our outside interface, I believe. I need to look at my outside interface real quick. I just want to put the same one so it's consistent. Oh, I think it's 1, 0. All right, let's imagine it is. So 1, 0 here is our outside interface going to the outside world. And then we have some inside interfaces that go to the inside world. So we'll label it in and out from a NAT perspective, just from a NAT perspective. So if this is an access list that matches, it says anything that starts with a 10 is a match. Thumbs up. Yay, that's it. Then we could include that access list as part of our NAT rules for dynamic NAT. And dynamic NAT means I'm not creating a translation in my translation table. I just have this rule. And if it's matched, then I'll kick into gear and I'll make a translation. I'll start using that. So a translation rule could look like this. In global config, we could type in IPNAT inside source list. Now, you may ask, well, Keith, how do you, like, you're not even at the command line. There's no context sensitive help. How do you memorize this? I've done this a few times. That's literally why I can do this, because I've done it a few times. And that's the same reason we should lab things up and practice. It just becomes more familiar. And if I write something out and it's not quite right at the command line, I can solve it. But you'll get more familiar with the commands. You don't need to memorize all the commands, but the more you lab up and practice with them, the more you'll have them available. So IPNet, I want to do inside source, meaning I want to do source address translation from traffic originating on the inside, which means traffic would be routed ingress on an interface that's associated with the inside from that perspective. And I'm making a routing decision, and that packet happens to be routing out an interface associated with the outside interface. Sometimes we call those ingress and egress. Once I was taking my Cisco lab, and they gave you a lunch break, and they this is a bad joke. Anyway, there was so you get your lunch, and there's a tray. There's a place to return the trays with the flatware and silverware and the stuff, the remainder of your lunch eating process. Why is that so hard for me to say? You know, you have lunch, and then you're done, and there's a plate and a glass and maybe a spoon or a fork. Okay, so you take that tray of remainder, and you walk into this little alcove area, and you put it on this like a conveyor belt, and it takes it to the kitchen staff so they can deal with those dishes, wash them, and so forth. And you're supposed to go in one way and out the other. It's very easy, because everybody goes in one way, they drop off their tray, and they go out the other. And I walked in the wrong way. I walked in the outdoor. And I just, afterwards, I bumped into somebody. I almost bumped into somebody. I stopped and said, oh, sorry, I'm going the wrong direction. And then I went back to the table, and I said, if they had signs that said ingress and egress, I would have been set. And that's like enter here, exit here. That's all that ingress and egress means. But when you have a lot of studying on the brain, and that's all you're thinking about, the word ingress simply means where it comes in, and egress means where it's going to be routed out, in this case based on a routing decision. So thanks for that little story. All right, so going back to this, IPNet inside source list 1, meaning any traffic that's coming in on the inside, I'm going to take, and based on the source address matching list 1, which says starting with 10 anything. So 10.2, 10.5, 10.17, 10.99, tax time. That would match. And then you have to say what you want to do. IPNet inside source list 1. And if we just want to overload those on the outside interface, we can just say interface and then gig 1/0 overload. And here's what that means in English. It says if, this is a dynamic NAT rule, and specifically it's an inside source NAT dynamic rule. And it simply says IPNet inside source if it matches list 1. So Larry's packet coming from 10.16.0.10 would qualify. If that matches, and we're going from inside to outside, which is what this IPNet inside command says, go ahead and map it to the existing IP address on this outside interface, which is gig 10. So we've already identified that as an IPNet outside interface. We're simply saying use that IP address, and overload says, do it again, Sam, do it again. What do you mean, do it again? Well, if you got Larry and Lois and Bob and Sally and Jeff and everybody else, Bob and Gus and everybody else on this form who's on that inside network and they're all going out and that traffic's being routed off that interface, if their IP addresses start with 10, just start overloading and use that same IP address over and over and over again for source NAT address translation. And then as those packets go out to all the cool sites like cbtnuggets.com or espn.com or twitch.com or youtube.com, the router is keeping track of all those sessions with unique port numbers. And if it's not a TCP or UDP segment, it also keeps track of it just for grins. And that way when the replies come back, because all this traffic is coming back to that one IP address, then the router is going to look at those incoming packets and say, okay, based on the ports I used as I sent those packets, because it's going to play with all this port information, it will then identify who it goes to on the inside, over on this side of the network, untranslate those responses back to the original addresses involved, and then send them back to their respective clients. Hundreds of thousands of times per second sometimes, based on your network traffic and how much you're doing that. So this is an example, going back to Murray's question, and I appreciate him asking that for the group, this is an example of dynamic network address translation, and specifically, it can be called dynamic PAT because we're actually using port address translation with one single IP address being overloaded. And the examples we did in class, where we just hard-coded and said inside source static, which is this guy here and this guy here, those are examples of static NAT. And in all cases, these are all examples. Everything I just described and we did earlier is all an example of source NAT, because on the initial flow, we swapped out the initial source address. And one thing about NAT too is that sometimes it's important to realize that if you do a translation, is that translation good for both paths? And the answer is it can be, and many times is. So if we do source address translation, where we have the inside address and the outside address, sometimes, not every time, but many times, that address can be initiated from the outside, meaning an outside device could hit that mapped address and have the translation work to the inside address with static NAT. And with port address translation, with dynamic port address translation, that's not going to be a problem because the translations don't exist until there's traffic that's sourced that matches the rule, and then that translation is used. So there's a lot to talk about with NAT. Again, the focus was local, means from Larry's perspective about the inside and outside addresses, his belief system. G, global, think of Google or some big entity on the outside looking at those same addresses. From the outside, what is the outside address, and the inside from their perspective on the outside, and that will help you decode show IP NAT translations. All right. Let's continue our questions. I appreciate you being here. Wow, we have almost 200 people today on a Sunday. Oh, it may not be a Sunday where you are. I realize that too, because the world's a big place and it's getting smaller all the time. I'm very grateful to have you. Okay. And Dan. Dan, thank you. It was enjoyed the live stream. It was me with the VLSM small to large lab. Tricky, wasn't it? Dan, thank you very much for three things. One, for bringing that up in Discord and then showing the results, asking the question, and encouraging me to validate it. So I'm giving Dan all the credit for the VLSM small to large, which I've never done in my lifetime. I've always done it large to small, and now I know why. Yeah, Dan, when I was doing that, I did it in Packet Tracer first, because why? Packet Trace is right there, just up. And then it failed. I thought, poor Packet Tracer. And it just can't handle it. It's not right. I looked at all the ranges. There was no overlap. There wasn't. But doing it small to high broke it. And I thought, okay, so a Cisco router is not going to make that same mistake. So I got up I say real gear. I brought up a virtualized environment of live gear and did there. And I was so shocked. I was so shocked to see that going from low to high just does not work. I thought, wow, it's sort of like the ham story. This couple got married, and I'll give you the short version. They got married, and one of the spouses cooked this ham, and before he or she cooked it, doesn't really matter. They always cut off the end, like a third of it, before they put it in the oven. And so the other spouse said, just curious, why do you always cut off a third of the ham before you put it in the oven? And that person said, I don't know, but my parent always just did it that way. And then they were visiting, their parents and asked the parents, how come you cut off that third of the ham every time before you bake it? And they said, I don't know, our parents. So long story short, they were at grandma's and grandpa's house one day, and they were asking the question, how come you always cut off a third of the ham before you bake it? And the grandma or grandpa, whoever was cooking that day, looks suspiciously and says, because my pan was too small. Why do you ask? That's such a weird question. And so for 3 generations, you've got people doing something that wasn't needed because of some original cause that the original person did it for, and everybody just buying into it. And so IPv4 VLSM, which we covered in Subnet Saturdays, I've always done it one way, and that is from large to small. I did not realize the implications of trying to do it from smallest networks to largest until then. So thank you for that and that opportunity to study it. So I guess I'm staying with my old trick method of large to small. And thanks for reminding me, Dan. Okay. Okay, and Darshan's asking a question about dynamic NAT. Okay, it looks like a statement. Awesome. Thank you, Darshan. Looking for my name still, going down a little bit more. Okay, in the command IPNAT outside source, are we translating the outside global addresses to an inside local address? Okay, let's take this one step at a time. I think it's great question, because I'm going to think about it using the techniques that I just shared with you about local and global. In the command IPNAT outside source, so that means we're doing the initial translation on traffic that's coming in on an interface from the outside that's going to be routed through an interface on the inside, IPNAT inside. So that's what the IPNAT outside command is about. And then the source keyword says we're going to swap out the source IP address of that traffic, of that packet. So then the question reads on, are we translating the outside global address, which is the real outside address from the Google perspective, what the real address is, to an inside local address? And local is from the perspective of Larry, the inside user. And that is exactly correct. Michael, I just want to make sure I'm not going to mislead you there. That's exactly what we're doing. We're translating it. In fact, let's go to a command line, and I'll show you the context-sensitive help, which confirms it. So in the syntax for IPNAT statements, it's like, oh, outside global, outside local, inside. What does that mean? Now, as we do the IPNAT commands for static NAT or other NAT, as we use context-sensitive help, it says local inside. We're going to say, oh, local inside. That's from Larry's perspective, the inside address. Great, which is going to be the real address. And if it asks us for the outside global address, that's going to be from the global position, from the outside network, what they think the outside address is, which once again would be the real address for that device on the outside network as seen by the outside. Let's do that. Let's go ahead and do a IPNAT outside source, and we'll demo that, because this is a great learning opportunity, which I want to take advantage of after I log back in. Okay, so we'll do a config T, IPNAT, and do we want to translate traffic as it's being sourced from the inside going out or the outside going in, or do we want to create a NAT pool? And there's other options here as well. So let's do IPNAT outside to match the question, and then it's asking us what type of network address translation are we doing. We're going to translate the source traffic for packets as they're coming in from the outside. And then it's asking us for, if we had a list, we could make an access list for matching on, or we could just say static. We'll do static for this example. And now it's asking us for the outside global IP address. Think about it. Global, whose position is that? Whose perspective? It's on the outside. So from the outside perspective's world, it is the address they're going to see for that address that's going to be translated, which in the case of our server was, I'll use another address, 192.168.1. let's say 101. I don't think that device exists. It doesn't. But from the outside perspective, using the context-sensitive help, from the global perspective, from the outside perspective, what is the outside's IP address? And so we'll pretend that's the real IP address on the server, on the outside of the network. And then we use a question mark, and what do we want to map it to? We want to map it to, from the local's perspective, what that outside address would like to appear as. So if we ask Larry, hey Larry, you're going to go to this device. In fact, you know what? Let's do this. I'm going to map. I hope this works. I'm going to map 55. Let me back up a sec. I like to see if I can get this to work. So outside global IP address. So let's imagine we have a device at 192.168.1.5 on the outside network, and from the global perspective, that's its real IP address, and we want to map it to I'm going to back up one more time because my brain just did a slip. I just want to make sure I'm going to do this correctly. Outside global address. Okay, so from the outside position, what's the real IP address? 192.168.1.5. And now it wants the outside local address. So from Bob's perspective, after the translation is done from outside to inside, which because we're doing outside source NAT, what do we want that IP address to appear as from Bob's position, local? What's Bob going to think that IP address is? And I think I would like to use this. I need something routable. Routing has to work. 10.16.6.99. And I'm also going to add a route for that too. So that syntax right there is the mapping from the global perspective, the outside address, to Larry's perspective of what that outside address is going to be from Larry's perspective. Yeah, that's right. Okay, I just want to look at it, make sure. So let's do a look at our rules. Again, I want you to take away the local and global. If you have those two down, then you can look at those perspectives for any of your mappings. Let's do a show IP NAT Translations. Okay, so now we have 3 rules, 3 static mappings, 3 static NATs. We have one that's inside source static for this guy. We have 2 that are for outside source NAT, which is this one and this one, the top one we just created. And from the from local Larry's position, it's reachable at 10.16.6.99. That's his belief, because that's what he believes the external or outside device is. But the outside world knows that as 192.168.1.5. Now, do I have an address out there at 1.5? Let's see if I do. And I do. So what I just did, I did a mapping, and I simply said this outside address of 192.168.1.5 is mapping to the internal, or what looks like from Bob's perspective, the address of 10.16.6.99. And so if we went to Bob's computer and we went to a command prompt, this is where my life changes. All right, let's do a ping to 10.16.6.99. I'm just going to check my translation table again real quick. So from Bob's perspective, local, he thinks that outside address is 10.16.6.99, which should really map to 192.168.1.5. That should work. So let's go ahead and test it. Oh crap. Hold on a second. 10.16.6.99. Survey says we have a reply, and let's go check out our translation real quick before it times out. It timed out. Yeah, let me do a continuous ping. -T, please. All right. I would love to see a translation here. If not, we can force it. So that's the router itself. Let's do this. Let's remove that, and I will change it. So that's just a Control A and a no, And I'm going to hit the up arrow key again, and I'm going to take off the 1.100 map to 10.16.6.100. And I'll make sure I got both of those. All right, so let's go ahead and add a translation to something that's reachable. And we'll do an IP NAT. Let's go up a little bit more. Okay, so what I'm doing here is I'm going to go ahead and map the address of the server again, just for grins. And I'm going to map it to the outside local address of 10.16.6.99. So from the perspective of Bob, some tips are hard to forget. From the perspective of Larry, he's going to think the IP address is 10.16.6.99 from his perspective. So I'm going to add that. We'll do a do show IP NAT Translations. And let me circle these real quick, and then we'll test it. Oh, did I do? Yeah, I did add route. That's good. So from Bob's perspective, he thinks that there's an outside IP address reachable at 10.16.6.99, and the outside world, from the global perspective, knows the outside address is really 192.168.1.100. And so as we forward traffic from Bob's computer, it's going to have bidirectional NAT again, except we're going to be doing source NAT here with this rule, and source NAT here with this rule. One inside source NAT, one outside source NAT, and let's test it. All right, so let's go back to Bob. 10.16.6.99 is the address that Bob believes is reachable as the server address they can reach. So let's, I've got the ping going to that address. So the stop. All right, now I'm going to close that, and let's bring up a browser. And let's go to 10.16.6.99. And that works. Let's also do a netstat-n. Just take a look at those ports, 1558 and 1559. So Bob believes my inside address is 10.16.0.10. On these source ports, Bob believes that the destination IP address he's going to on the outside world is 10.16.6.99, and our NAT table should reflect that. So show IP NAT translations. There they are. Also, we got an ICMP one from our earlier pings. That's fine. So there is the inside local from Bob's perspective. Oh, for Pete's sake, Larry, come on. This is the only discussion I use Larry consistently, or tried to, because of the Larry being local. So Larry thinks his local inside address is 10.16.0.10. Larry thinks the outside world he's going to is 10.16.6.99 from his perspective, and from the outside world sees those addresses as really 192.168.1.100. From the global perspective, those addresses on the outside are really what they are. And from the global perspective, it believes, the outside world believes, those packets that are coming in are coming from 192.168.1.10 with their respective ports. And those ports match up exactly with what they were in the NAT translation, because it's literally what's happening. All right. So that was a great question. Thanks for giving me a chance to elaborate on that and have some fun. Larry's local. Good thing. I love that Larry guy. Always looking at the local perspective, what he thinks the addresses are on the inside and the outside, and then global, what its opinions are of addresses on the inside and outside. Two different perspectives, talking about the same flow of traffic, but because the addresses change as they go through NAT, it's important to see. All right. Scrolling down for any other questions. Darshan, you're welcome. And just see if there's any more here. And John is mentioning, I use NAT in VMware on Home Lab and using NAT again on physical router. Yes, NAT, service providers are usually going to be performing NAT multiple times before your traffic actually gets out to the internet. So if you have a home router and you're connected and you look at your router and it says, my IP address is 10 dot something, or my IP address is 192 something, the WAN interface, not your local side, but the WAN interface, and you're learning it via DHCP or PPP over Ethernet if you're using DSL, those addresses that they're giving you, if they're private, they are doing translation later down the path as those packets go out to the internet. So yeah, doing that multiple times is a common thing in Very, very common. All right. It is, wow, it's almost 1 o'clock Pacific time. That makes it 11, 12, a 2-hour stream, 1 hour, 1 hour and change for the content, and then 1 hour for Q&A. I had a lot of fun, and there's 167 people live right now. So I appreciate all your time in joining me, helping other people learn. I'm having a blast doing this. A couple tips for the road before you leave. With the new coronavirus, COVID-19, I know this is old news, but it's a respiratory infection, and the only way it can really get in you is through your mouth and your nose. And so the benefit of wearing a mask is not to prevent the vapor droplets from getting in. I mean, somebody would have to really sneeze right on you for that to happen, but most of the time, people sneeze or they cough, and there's virus from an infected person, if that happens, on everything around them. So they're touching their mouth, their nose, that virus is getting on things, and then we touch those things. Like, man, it's just it's tricky too. It's tricky. I went to a thing last night, and I was shaking hands and hugging people, lots of people. And I thought, I think if this outbreak happens more seriously in the country that I'm in and the state that I'm in, I got to be way more careful, because we touch things that other people touch, and then we put our hands in our mouth or our nose, like me, like this little thing I call a beard, this semi-beard. I'm touching it all the time, like this. And that's a habit that if I'm out and about, I need to be aware that anytime you're in a public space, if you're concerned about not infecting other people, which is important, also not getting infected, is that you just got to not touch anywhere up here unless you wash your hands very thoroughly for 20 seconds or so, thoroughly with soap. And if you don't have soap, you can use hand sanitizer if it's like 60 plus or 70% alcohol. But that's the interim solution until you can actually wash your hands. So it's going to take some change of behavior on a lot of people in the country and the world, and it's coming. So this is nobody likes to get sick. So a lot of people are not going to die from this, but they will get very, very sick, and that's no fun. So to protect yourself, the mask, if a person wears a mask, it's not really to filter out the vapors. So it doesn't have to be a high surgical mask or with vents and everything else that are, to filter out poisons and chemicals. It really is acting like a dog cone that helps remind a person that, I've got a mask. I can't touch my face, my nose, and my mouth, because that's how this thing is infecting people. So if you've heard that already, great. If you haven't heard that, I want to point that out, that the mask could be a good reminder about not touching your face, washing your hands frequently, and because the incubation period is pretty long, where people have it and they don't know it yet. When it breaks out, the infection could be pretty hideous. All right, so that's my public service announcement. So back to CCNA. I enjoy what I do. Love having you here. If you haven't already subscribed, let other people know you're watching this. If they want to get their CCNA, we have a lot of fun in these sessions. I'm going to be covering a lot of the topics on the CCNA blueprint. Probably not all of them in full totality, but a lot of the ones where I can add value. That's where we'll be adding them. Coming up, we're going to have IPv6 routing, which is going to be very important. We also have Subnet Saturdays we're rounding out, and I also really appreciate your comments. Oh, Murray's asking about my new studio. And he asked me if you don't take pictures, it's not real. So I took some pictures. And let me see if it shows up here. All right, that's not my studio, that's my cat. But I do have a video of my studio. Let me show you some snaps. So it's currently a workshop area, and let me see if I can get the focus on that just right. Nope, it's not going to happen. All right, I'm making a video or a documented process of me creating it, and stuff is coming out, new stuff is going in. It'll probably take a few months, but my goal is to get it done before the end of 2020 to have that fully operational, fully functional. So thank you for the recommendation. It is coming along, and it's going to be a lot of fun. I have one little problem though. Because it's a workshop, I've currently got the water softener in the corner, and so I'm thinking maybe I leave it there because I don't have to replumb that and the whole laundry. It's like maybe I'll leave that there, and maybe I'll also I have an elliptical that I'd like to have somewhere at that property, which I currently have here. So I was thinking maybe I'll put the elliptical like in one corner, one end of the room, and then have a curtain for noise deadening, and then use the rest of it for the studio. We'll see. I'll let you know. I'll build a collection of pictures, and I'll put it all together in a video near the end. So it'll be several months of work in a 4 to 5 minute video. Yep, Michael, good observation. And let's see here. Victor's asking, if I have a topology with several firewalls and several routers and several switches, which device should do the NATing for the network? And the answer to that, that's a good question. Like if I have 3 devices that could do NAT, which one should do NAT? If you have a firewall in that mix, that's the device that should be doing your NAT because it's purpose-built. It's got better hardware for that purpose, and it has more CPU oomph focused to the energies of defending the network and stateful filtering. And because it's doing stateful filtering is a fancy way of saying, let's imagine you and I go to an amusement park. So we go to the amusement park, we pay more than the stock price to get in. So we pay $100 or whatever. We go in the amusement park, and then we need to go out to our car. Well, when we leave, if we need to go out to our car just for a few minutes and we want to come back, we don't want to have to pay again. We need some way of proving that we've already been there. So what they used to do, they used to stamp our hands. So we'd have this stamp, and they could check it with an ultraviolet light and verify the stamp. And that's sort of like how a firewall works today. So Larry, or Bob, on the inside of the network, as he's going out, there's probably NAT involved. As he's going out, a stateful firewall is going to remember that session. It's going to allow, permission-wise, for Larry to make that initial connection going out. At the same time, there's going to be some NAT who's tracking that session, doing source address translation to a globally routable address. So the traffic goes out, and then when the return traffic comes back to Larry, it untranslates, that's the NAT part, and then the firewall is permitting that traffic from the outside untrusted world to come in from a permissions perspective because it maintained a state table, like a rubber stamp, that Larry's packets went out, they got stamped on the way out, remembered, and then the reply traffic, if it's correct for Larry's session, it would dynamically allow it back in. So I would say that if you have a firewall, that is very likely, and all your traffic's going through it, that's very likely the best place to do your NATing in a production network because there's security benefits to that as well. And also you can just manage it all right there. Here's the NAT, here's the security permissions and so forth. So thank you for the question. Oh, and Michael's all over it. I should have looked at Michael's feedback. Thank you. Thank you for everybody's helping with other people's questions. And Nathan, you are very welcome for the stream. Glad to do it. And everybody else who has kind words, thank you for being here. And I don't see any other questions. So it is Sunday, at least in this time zone, Pacific time zone. Our next stream is on Wednesday. And Wednesday, we're going to bring another CCNA topic. I haven't identified it yet, but I will publish it out on Discord. And I will also publish it out on LinkedIn and Twitter and Facebook. So if you're on any of those platforms following me, you'll know about it as well. And enjoy your week. Have a great one. It's great to get to know you better. I feel like I have a better knowledge of the people in this community based on your questions and in Discord, and I'm having a great time. So persist in your studies. It is definitely worth it. You can definitely do it. And I'll see everybody, as I find my exit button, I'll see everybody in the next live stream. Thanks, everyone.